In 1995, astronomers pointed the Hubble Space Telescope toward a bit of what looked like blank space and started taking pictures. Over the course of 100 hours, they took 342 images and the result was incredible. The image, known as the Hubble Deep Field, peered back to almost the beginning of time, including 3,000 galaxies. Since then, other deep field images gave even more spectacular views. Now, as Nancy Atkinson reports for Seeker, a new deep field image taken by the MUSE instrument on the European Southern Observatory's ESO Very Large Telescope in Chile has peered even deeper into space, identifying 72 new galaxies. Even more importantly, the telescope gathered spectroscopic data on about 1,600 other galaxies, 10 times more than astronomers have been able to compile over the last decade, according to a press release. To make the observations, the ESO team pointed a multi-unit spectroscopic Explorer MUSE instrument at a spot of sky near the constellation Fornax, the same region in which a 2004 Hubble Ultra Deep Field survey found 10,000 galaxies, some of which were around 13 billion light-years from our own planet. MUSE examined the spot for 137 hours over 2 years. The researchers detailed the results in 10 papers published in a special issue of the journal Astronomy Astrophysics. So how can the Earth-bound telescope gather more data than the space-based Hubble telescope? It would seem that the light pollution and radio interference on the Earth's surface would make such detailed analyses impossible. But, according to Roland Bacon, leader of the research team and researcher at the Centre de Recherche Astrophysique de Lyon, the stature of the Very Large Telescope does things its aging space cousin, launched in 1990, was not designed to do. MUSE can do something that Hubble can't. It splits up the light from every point in the image into its component colors to create a spectrum, he says in the press release. This allows us to measure the distance, colors and other properties of all the galaxies we can see, including some that are invisible to Hubble itself. The 72 new galaxies discovered are not actually visible to the Hubble. That's because they only emit Lyman alpha light, a faint type of radiation created in the earliest stages of galaxy formation. We were surprised, Jarl Brinkman, lead author of one of the new papers, tells Atkinson. Finding new galaxies is in itself not so exciting. We find loads everywhere we look if no one has looked there before. But this was the best studied part of the sky, with the deepest images that have ever been obtained. That's not to say Hubble is obsolete or that its successor, the James Webb Space Telescope, which is scheduled to launch in 2019, is unnecessary. Brinkman says that the data collected by Hubble was instrumental in understanding the observations made by MUSE, since it allowed researchers to differentiate objects that appeared to be blurred together due to Earth's atmosphere. As Elizabeth Howell at Space.com reports, MUSE also detected hydrogen halos around some galaxies. Studying these features could help astrophysicists figure out how matter enters and leaves galaxies. MUSE's observations could also illuminate galactic winds and mergers, star formation and something called cosmic reionization, which could help explain how the first winks of light in our universe came to be, like this article. Sign up for our newsletter.